so far this semester, we talked about how to collect data and trying not to have any bias. We talked about all the different ways you can collect the data, systematic sampling, cluster sampling, and so forth. We talked about the types of data, quantitative, categorical. We talked about how to make graphs to display your data. But sometimes we use numbers to describe our data. A lot of you have used numbers to describe data and understand it in your whole life, you just never really thought about it. If I said the average age in this room is 20, that's describing everybody in this room in a sense. If I say the average age is 20, you know, that's around the middle. Some people are younger, older. How would I have calculated the average age being 20? If it was 20, what would I do to get that? How do I calculate an average? You did this before you met me.
Add them all up and divide.
Thank you. Add everybody's age up and then divide by however many are in here. 40 people in here. Add everybody's age, divide by 40 to get the average. And maybe it turns out to be the average age is 20 years old. So that's a number that describes what's typical, what's in the middle. So everything in section 3.1 is describing what we call measures of center. 3.1, hopefully you corrected your notes, right? 3.1 measures of center on page 24. Measures of center are what's in the middle. The definition of middle changes though. That's why it's plural measures of center. The word average that we just talked about is no longer going to be used. We call it the mean. In parentheses, I'm going to put average right here, because that's what most of you already knew about average. So section 3.1 talks about lots of ways to talk about the middle of the data. And there's many of them. The mean is one of them, and it even says to do what we're supposed to do. What Kevin just told us. Add all the data, divide by the total number of values. So if there's 40 people in the room, I'm going to add up 40 ages, divide by 40. We're now going to be calling that the mean from now on. Not the average anymore. It's called the mean. Look at that scary formula. I love scary formulas. Get your heart rate up a little bit. We're going to talk about what this means. There's this formula over there on the side of your notes. I'm going to start with the bottom because it's easier. There's a little letter N there. N for the whole semester will represent your sample size, the number of data points in your group. So N is the sample size. So in the example I just spoke about, because there are 40 of you in here, N would be 40. Right, if I added up all 40 ages and divided by 40, I have a sample of size 40. The X's, just regular X by itself, is each of the data points. So I asked one person how old they are, this person's 18, this person's 24, this person's 19. Each of those is a different X. This funky symbol right here is called a sigma. It's a Greek sigma. And it tells you that we want to find the sum. It's shorthand math notation, number one, to scare you, which already, I think I succeeded in scaring half of you with it. By the way, there's lots and lots of scary formulas and statistics, and I will break them down to make them not scary, or tell you to ignore them and use a calculator sometimes. But this means sum. Find the sum, meaning add. Add all the X's. So if I take all your ages, those are all my X's. So we just said we're going to add all the ages and then divide by 40. This is just shorthand for telling me to do that. Add all the data points and then divide by how many you have. Don't let it freak you out.
So what's the X line on it?
We read this as X bar. That's how we say it. In words, it's the sample mean. The mean from your sample. So let's say I was interested in the average age of all LMC students. I took you guys as my sample of size 40, and I got the sample mean. I would find that X bar was 20. So in this room, the average was 20. The mean was 20. So we call it X bar when we speak about it, but it represents the sample mean. I'm glad you asked. Because next to it is another weird symbol. Other questions? So this other weird symbol, this letter's kind of weird. The font on your paper is better than the way I can draw it. But I claim it kind of looks like a U and it kind of looks like an M. Do you agree with that? Mm-hmm. Its name in Greek is mu. Looks like an M, looks like a U. I think that's hilarious because I'm a math nerd. You say it like a kitten. Mu. Mu is also the mean, but it's the mean of the population. This is where people start to get confused. The notation matters. So remember I said I'm interested in finding the age of all LMC students. If I'm interested in finding the age of all LMC students, I'm looking to find mu for the whole population. But because I don't have time to go find everybody, and I have you here as my captive audience, I'm going to find the average of just the 40 in this room, which would be a sample mean, which is X bar. They may or may not be the same. I might find that the average age in this room is 20, but the average age of all LMC students is 22.9. So these may not be the same. They both refer, I was going to say they both mean a mean. They both refer to the mean. So a lot of people will ask me, wait, Jill, I thought you said X bar was the mean. And I'll say, yes, I did. Well, then you're telling me that mu is the mean. And my answer is, yes, it is. What's the difference? Sample and population, good. This notation over here looks almost the same. Add all the X's. Guess what capital N is? The population size. How many people in the whole population? The X's are still all the ages. So one of the reasons we learn statistics is it's just logistically difficult to go get the population mean. I don't have time to go find all 10,000 plus students out there, get all their ages, add them all up and divide by 10,000. That's a lot. But I can easily take a sample and take the mean from my sample and use that to estimate what it would be for my population. Are the formulas slightly less scary? A rule that you'll find throughout the semester. When things are written in Greek, like here's a mu, next time you'll see some other ones. If they're written in Greek, they're referring to the population. If they're written in our regular letters, X and N and so forth, even with the bar over it, it refers to your sample. So next time, I'll give you a preview. We'll see an S, and we'll see this weird little Greek that's a sigma actually. This represents this comes from your sample, this comes from your population. So a lot of times you'll see Greek letters and regular letters and they mean the same thing, but it's just like this. Some refer to your sample, some refer to your population. We're going to break that down more next week. The Greek letters start freaking us out. They're all over statistics. Okay, so that's the mean. The next one down is the median. The median is the middle value when the data are placed in order. I actually mentioned that earlier when we were looking at our first stem plot. Remember I asked you for the number right in the middle of the stem plot? We figured out it was 30. So most important, you might want to underline this part, the data have to be placed in order. Don't just count to the middle of your list. They have to be in order from smallest to biggest, and then you find the one right in the middle. I catch everybody, every semester, not everybody. I catch at least one person every semester on the exam who give me the wrong median because they don't put their data in order. I'll give you some problems that are in order and I'll give you some that aren't. If you don't put them in order, you're going to get the wrong answer. So let's talk about a nice little short list. Let's make up some numbers. I'm going to put them in order as I go. Here's a nice little short list of data. What is the median of that list? 10. The one right in the middle. We agree 10's right in the middle? If they're in order, which I put them in order on purpose. If they weren't, we'd rearrange them. This is the median. The number right in the middle. But look what it says. If there's no middle value, find the mean of the two middle values. That's like what we did with that other problem. I don't remember what it was. I'm just going to make up some numbers here. I know we were talking about 28 and 32 were the two that were closest to the middle.
Yeah, so.
Yeah,
we should
and-
just average them, or,
Go ahead.
don't you just add them together and divide by two?
Yeah, there is no one number right in the middle here. Like the middle's right here somewhere, right? So we take the two numbers in the middle and find, she's calling it the average, but now we're going to call that the mean from now on. So halfway between 28 and 32, we add up however many numbers we have. Take that answer, divide by 2. You'll end up with 60 divided by 2, which is 30. This is the median. So you'll be given a list of numbers, maybe like this, they'll be longer. And you'll be asked to find the mean, find the median. How would I find the mean of this list? I didn't hear you said. Somebody said something. What was that?
It's me.
Oh, I didn't hear you said that.
I'm not sure if I'm right. So add all of them.
Add all of them. If we wanted to find the mean of this whole list, we would add all these numbers up
And then divide by both.
and divide by 4, because there's 4 numbers in our list. That's what that formula was we were talking about here. If we want to find the median, we just know to find the number in the middle. Either just grab the one in the middle, if they're in order, or average the 2 in the middle and find the mean of the 2 middle ones. Be careful because you're going to get confused because both of these are measuring what's the center of the data. The word center is really wishy-washy here. Which one's a better descriptor of the data? It's hard to say which one's better. It depends on situation to situation. In this case, the median is 30. Let's find the mean of this one. Can we find the mean of that set? Let's find x bar for this set right here. 6 plus 28 plus 32 plus 70. I'm hoping somebody has their calculator out. I can't do that in my head. 34? Got people agreeing with her. I heard someone else go, what?
33.
33? Did we round? They add up to, let's see, what do they add up to? 60, 136 divided by 4 is 34?
Yeah.
I'm hearing 34. Make sure you add first and then divide. So this is a measure of center. And this is a measure of center. With this short list, we could sit here all day and argue about which one's better. But we're just kind of describing what's typical. And what's typical is if you spread them all out evenly, everyone's around 34. This is saying that exactly half of the people are older than 30 or younger than 30. There's not only one way to talk about what's typical. The next one down here on your paper is the mode. That's also used for what's typical. That's the number that shows up the most. It shows the most often. I don't have a mode in any of these short examples I just made because there's no numbers that repeat. The previous problem we did with our stem plot earlier had like a whole bunch of 6s, I think, probably more than anything else. I think we had like 3 people that were 6. We'd have to look back at it. But that would be the mode of that one because that number showed up more than anything else. Imagine if you walk into a kindergarten classroom and you took everybody's age. And you've got, this person says, I'm 5, I'm 5, I'm 5, I'm 5, I'm 5. Oh, look, here's a 6-year-old. And I'm 5, and I'm 5, and here's the teacher who's 43. Just don't have a teacher there, right? If we averaged and found the mean of that data, that wouldn't be very typical. Because that 43 would kind of affect the mean, right? We found the mean, we would get that it's probably the average age in there is 8 or something. Or nobody in there is 8, right? So it doesn't make sense to take the mean there. The median would make sense because if you put them all in order, you'd have 5, 5, 5, 5, 5, 5, 5, 6, and 43. And so 5 would be in the middle. So the median would make sense. And the mode would make sense because the mode, the 5 shows up more often. That describes what's typical. So depending on the situation, sometimes the median makes more sense. Sometimes the mode makes more sense. Sometimes the mean makes more sense. It all just kind of depends on what you're doing. There's a lot of times when we don't use the mean And that would be a good example, because it throws off your results. If I found the mean in that kindergarten classroom, let's make it a really small class just in the interest of time. A very lucky teacher only has a handful of students. Here's the class of how many students, and then there's the teacher. Someone grab their calculator for me and tell me the mean of that list. My kindergarten class here. I've got 1, 2, 3, 4, 5, 6. I got 7 5-year-olds, a 6-year-old, and a 43-year-old teacher. Ten and a half? We agree with her? She added them up, divided by, I don't even know how many numbers are there. Are there 8 numbers? I don't know. She could be wrong. I'm waiting to see if someone agrees or disagrees. There's 9 numbers? Oh, so maybe it's not 10 and a half. Speak up. She's willing to admit she's wrong.
9.33.
9.33? Someone agree with that?
Yep.
You got outvoted. It's okay. We learned from our mistakes. 9.33. This is where if the rest of you hadn't spoken up, I would have left it to 10 and a half. She and I would have thought she was fine. And then later on, someone would say, Jill. Poor people watching the video are going, where'd they get that? Should correct it for the people watching the video. 9.33. The average person in that room is not 9 years old. There's nobody 9 years old in that room. So the mean in this case is not very helpful. What if the teacher was, she's real close to retirement, she's like 64. What would happen if she was 64? The mean would go up even higher if she was 64. What about the median?
5.
The median's 5. The number right in the middle is 5. Even if there's 2 numbers in the middle, they're going to average out to 5. How many numbers do I have here? 9. So 1, 2, 3, 4. This one's right in the middle. Right? Is that one right in the middle? Yeah. So my median is 5. My mode is 5. Ends up with the same. Both of those are better descriptors of what's typical in this classroom, or better measures of center in this case. Outliers, you're going to see that in your homework. Outliers are numbers that are way far away from the other ones. They don't fit in with the rest of the group. This teacher is an outlier, obviously. The outlier affects the mean, but doesn't even affect the median or the mode. Doesn't affect it at all. A good example of where you'll see the median used instead of a mean, because most of us here averages and are comfortable with that, is if you ever look online at, say, like housing prices. If you look at housing prices, they almost always give you the median house price, not the mean house price. Same with salaries. Because imagine if we were talking salaries, and I asked you how much you got paid per hour. I would assume, I don't know what you all do for your jobs, but I'm going to assume that most of you, a lot of you probably have minimum wage jobs. Maybe some of you moved up a little bit and are making in the teens. Maybe there's someone who makes $30 an hour. That's a pretty nice job. And then I'm also going to ask Steph Curry how much he makes per hour. I don't even know. I'm going to guess what that might be.
Probably like 500,000.
500,000 an hour, maybe? We'll go with that. It might be a little high. Maybe it's only 50,000 an hour.
Yeah.
We'll give him 50,000 an hour.
That's like a game.
Yeah. Yeah, depends if it's game. You can include practice. He maybe doesn't get quite as much per hour. But this is all of our hourly wages. If we wanted to add those up, find the mean, we'd be all feeling pretty good about how much we make if we really all got the mean. And instead of with us each getting our individual salaries, we're just going to change it and make sure that everyone gets the mean. The rest of us are now really happy. Who's already calculated that now? Everybody do the mean already? I get calculators going, I assume someone's doing it. We all agree that 50,000 is going to mess up the mean, just like the kindergarten teacher over here. So the mean is affected by outliers. It doesn't make sense to talk about that the average salary is, who's done it now? Someone's done it, I know. There's always somebody who just wants to do it while I'm talking. Nobody? Someone quietly calculate the mean, let me know when you've got it. I can do the median. That would be this one. Typical in this room, $13 an hour. Half the people get less than 13, half the people get more than 13. Did you get it? Good try. So the median is 13. The mean, someone's gonna tell me eventually, what's the mode? 10. By the way, if there is no mode, you just write that, no mode. If there's no number that shows up the most often anyway, there is no mode. Because more people get 10 than any other number. And the mean is, who got it?
It's 7,000.
Go ahead.
7,000.
We'll see if we agree. 7,000.
7,155.71.
7.4?
1.
7.1? Is that what you got too, Lexi?
Yeah.
On average, we each get like $7,000 an hour. I like this job. I'm feeling pretty good about this. Sometimes the average makes no sense because those outliers do exactly that. Housing prices are the same thing. If you were talking about housing prices here in Contra Costa County, there's houses that sell for $300,000, $400,000, $500,000. There's a whole bunch in the probably like the $400,000, $500,000, $600,000 range. But then there's one house that's much nicer on a huge plot of land, part of a farm, and it's going to sell for $3 million. So all the other houses are, $600,000. Then there's this $3 million house. If you average that and say, oh, the typical house in this county is, in the 800,000 range, that's not true. We talk about the median because most people want to know, what can I afford? If you told me it's 800,000, nobody would show up because it's not the middle. You want to know, oh, some are lower, some are higher. So the middle or the center changes based on what you're trying to find. We're okay with the first three? The last one there is the mid-range. Halfway between the smallest and the largest, so there's a weird space on mine, there probably is on yours too. Halfway between the smallest and largest data values. Let's use my example over here. Here's the smallest, here's the largest. How do I find the halfway points between those? Add them up and divide by 2. It's another mean, really. So the mid-range in this case would be 10 plus 50,000 divided by 2, which is, I think, 25,005. Is that right? Someone help me out. I'm doing math in my head. Thank you. Is it? Yep, she did that. So these are all different numbers that describe what's typical of these hourly wages, if I could speak. We could say $13 an hour is typical. We could say $7,155 an hour is typical. We could say $10 an hour is typical. We can say the 25,000 and some change is typical. In this example, because of our outliers, what's typical gets really messed up. It gets affected by the outliers here, on the mean and the mid-range. You'll see a couple questions with your online homework that say, which of these measures of center are affected by outliers? This is like the worst. I don't know who uses mid-range for anything. It just doesn't make sense to me. I understand how to calculate it, but I can't come up with an example of where it's a really good measure of center. I have to do some research on that. Because it just takes the two extreme values and ignores everything in between. Yeah, what if I lifted up somebody here too, like if somebody didn't work, it would be a 0. Average would, it would change everything. Okay, middle of the page, 24. The round off rule. Online, it will always tell you where it wants you to round. But sometimes the textbook, you could like checking your answers in the back, you'll go round in places, like how do they decide where they're rounding? We always carry one more place than the original data. What that means is that, these are all whole numbers, for example. So when I find the mean here, see how we went to 7155.71? We would have just gone to the 0.7. Let me erase that. I'll remind you. One more decimal after whatever the original data was. If everything had 2 decimals, we would round to 3 decimals. You always just go one more. That's the round off rule. I'm not real picky about it. I will tell you where I want you to round. The computer will tell you where it wants you to round. But sometimes if you're checking the back of the book, how they know to round there? It's one more than the original data.